Hello guys, welcome back to the Data Structures and Algorithm course brought to you by Asha Foundation. In this lecture, we will going to discuss two topics. One is array-based stack, and then we will discuss about queues. We will briefly discuss array-based stack, and then we will directly jump to queues. So, array-based stack is just the implementation of a basic stack using an array. To do that, we first create a stack using an array by specifying a maximum size n for our stack, and we can take an example for n as 1000. The stack consists of an n element array S and an integer variable t. The index of the top element in the array S. Array indices start at 0, so we initialize t to -1. So this would be the pseudocode for the array-based stack. So for the size function, the algorithm would be just return t plus 1 because this is the variable we have initialized, and for is empty, we'll just return whether t is less than 0 or not. So if t is less than 0, it will return true, otherwise it will return false. For the top function, we will see if the stack is empty, then we will throw a stack empty exception because there is no element in the stack. Otherwise, we will return the last element of the array. For the push function, if the size of the array is equals to n, which was the initial size we have the initial size of the array, we'll then throw a stack full exception, which will tell us that there is no space present in the stack for the push operation, and if if the size is less than n, we'll just increment the index, and we will uh, put that element of the from the push operation in the array. For the pop operation, we will see if the array is empty, then we'll throw a stack empty exception because there is no element present in the stack in the array. Otherwise, if the array is not empty, we will just uh, take out the last element from the array, and we will make that last element null, and we will decrease the index, and we will return that value which we have taken from the array. So each of the above method runs in constant time. The array implementation is simple and efficient. There is an upper bound b on the size of the stack. So this is the bottleneck of this algorithm. But if we set this upper bound as uh, pretty much higher, this algorithm or this implementation is the best we can get. This is the Java implementation of the array stack. You can see we have first defined the capacity is 1000. Then we have declared the object array. We have declared the top index as -1. Then we have this constructor for array stack. And these are the operations which we have discussed previously in the pseudocode. I will request you to take a look on this algorithm and understand the implementation properly. Now we will come. Now we'll move forward to the next topic of our lecture, which is queues. So, queues is a very important data structure in DSA. You can imagine of a queue data structure as simply as a general queue you can see outside your office, your grocery store, or anywhere else. Queue store arbitrary object, and insertions are at the end of the queue and removals are at the front of the queue. As you can see, this is a normal queue outside the office security gate. You can see if you have to insert a person in the queue, you can insert it from the end, and if you have to remove a person from the queue, you can remove it from the front of the queue. So there are two major operations in the queue. One is enqueue. Enqueue means you have to insert an element at the end of the queue, and dequeue means you have to remove and return the element from the front of the queue. Other queue operations are front, size, and isEmpty. front operation returns the element at the front without removing it. It is just like peek function in the stack. Size function in the queue returns the number of elements that are present in the queue. Is empty operation tells whether the queue is empty or not. So now first we will see linked list implementation of queue. We can simply implement queue data structures with linked list. We will first have to initialize two pointers, front and rear. Front will point to the first element of the front of the queue, and rear will point to the rear end of the queue. So I will provide the code for the actual implementation in the description, but I will request you all to please implement this on your own. So this is how the queue class would look like. We have two pointers in the form of node. The one is front and rear, and then we have two variables size. This is the constructor that first in the constructor we just initialize rear and front as null and size equal to 0, and is empty return whether the queue is empty or not. So it can be if the rear pointer is null, that means there is nothing present in the queue, and if it is not null, that means there is something in the queue. Now let's see how to implement enqueue operations in the queue. So in the enqueue operation, we have to insert an element at the rear of the queue. That means we have to redefine the rear pointer. So in the enqueue function, we take some value. We will first initialize a node for that value, and we see if rear is equals to null, that means this is the first element that has to be added in the queue. We will set front as the newly formed node. Otherwise, if the rear is not equal to null, that means there is something already present in the queue. We just set a link between the rear and the newly formed node, and then we will set the rear pointer to as the newly formed node, because this is the last node which we have added, and we have to also increase the size, so we will increase the size variable. Now let's see how to implement dequeue operation. So in the dequeue method, we have to just remove and return the front element of the queue. So as you can see in the code, we have stored the data of front pointer, or you can say front element, in some variable d, and then we have set the front as the next element present in the queue after front, and we see if front is equals to null, that means our stack is empty, and we will also set rear is equals to queue is empty, and we will set the rear pointer as null also, and we will at last we also have to decrement the size, so we will do size minus minus, then we will just return the data which we have already stored previously. So that was it about enqueue and dequeue. Now see how to implement peek operation. Peek method, or you can say front, in C++ we have this method as front, so this will just return the reference of the front element of the stack but does not move it. So it is simply that function. It is very simple, so I will not discuss it over here. Now I will give you some exercises for the queue data structure. You have to discount the output and final structure of the queue after the following operation. These are the operations which we have to do in the queues, and you can write down your answer in the comments below. I will request you all to pause the video over here and give the answers in the comment section right now. Now let's move forward and see some applications of queue. Queues are used to while accessing shared resources. Example, printers, or in your home network you have multiple resources and you have to share them. So over there queues are used. Queues are also used in simulations of real world situations of waiting lines. As I have discussed, queues are just simple general lines which we see in the physical world, as you can, in flight booking lines and bank lines, etc. Queues are also used to efficiently maintain a first in first out order on some entities. As we have discussed that we can only insert an element from the end of the queue and remove an element from the front of the queue. That means it follows first in first out order. So we have to to implement this order in the computers, we use queue data structure. In multitasking operating systems, CPU cannot run out all jobs at once, so jobs must be batched up and then scheduled according to order in a queue. So over there also queue data structure is very important. Like this we have many other applications, but for now we will just discuss these only. So this was the end of this topic, and in the next video we will discuss about trees. From the next video, all the lectures will be made by my partner and my co my and co-instructor of this course, Samad Shahid. And if you have any questions regarding the lecture or anything about DSA, you can comment down below, or you can also reach out to us at our Insta and Facebook pages. So till then, stay safe, happy learning. Hope to see you in the next lecture. Bye.